The Hongdu K-8 Karakorum occupies a unique space in modern military aviation. It is designed primarily as an advanced jet trainer while retaining the capacity to perform light attack roles, offering an affordable and practical solution for air forces seeking a transitional platform between basic trainers and frontline fighters. Born from a Sino-Pakistani collaboration, the K-8 blends simple, robust engineering with training-oriented ergonomics to provide trainee pilots with a credible, reliable, and cost-effective stepping stone toward high-performance combat aircraft. From its external lines and functional airframe to the cockpit layout and propulsion choices, the K-8 emphasizes pilot training effectiveness, maintainability, and export adaptability. Externally, the K-8 presents a purposeful, unpretentious silhouette. It uses a mid to low wing design with moderate sweep, optimized not for supersonic performance but for predictable handling across a wide speed envelope. The fuselage is conventional, with a single turbofan housed in the rear fuselage and air intakes positioned low on the sides, an arrangement that supports stable airflow into the engine while simplifying maintenance. The K-8's canopy is framed for excellent all-around visibility, critical during formation flying, instruction, and low-level navigation tasks. The canopy's design increases situational awareness for both the instructor and the student, allowing effective visual scanning and easy communication during flight lessons. The tail assembly follows a conventional layout with a single vertical stabilizer and horizontal stabilizers, delivering the stability and control characteristics desired for training tasks. Practicality governs the K-8's external choices. Attachment points under the wings and fuselage permit external fuel tanks or weaponry, turning a pure trainer into a light attack platform when required. Typical loadouts include rocket pods, unguided bombs, light guided munitions, and an optional gun pod or internal gun module depending on the variant. Paint schemes and finishes vary widely among operators. Training units often prefer high visibility or muted gray liveries to suit training ranges and peacetime operations, while export customers sometimes adopt camouflage patterns for operational roles. The K-8's airframe prioritizes durability and ease of service. Common materials include aluminum alloys with localized composites in non-primary structures, striking a balance between structural integrity and weight savings while keeping production and repair costs manageable for nations with modest defense budgets. Stepping into the cockpit, the K-8 is laid out with training and ergonomics foremost in mind. The aircraft uses tandem seating, with the instructor in the rear cockpit and the trainee up front. This arrangement mirrors the seating found in most operational fighters, easing the transition as pilots progress to higher performance platforms. Control ergonomics are intentionally familiar. Centerline stick and throttle configurations, logically grouped instrument panels, and clearly labeled switches make procedural training efficient. Early K-8s used primarily analog gauges with conventional dials and indicators, reflecting the era in which the type was developed. However, upgraded versions and operator-specific customizations often incorporate modern glass cockpit elements, multifunctional displays MFDs, digital engine and flight parameter readouts, and improved avionics suites for navigation, communications, and mission management. These upgrades improve the training value by giving student pilots exposure to digital systems similar to those they will encounter in modern frontline fighters. The canopy provides excellent visibility, and environmental control and pressurization systems make extended high-altitude and instrument flight training comfortable. The aircraft is typically fitted with ejection seats, ensuring pilot safety during emergencies, a non-negotiable feature for any trainer operating in demanding flight regimes. Instructors praise the K-8 for its forgiving handling characteristics, stable approach and landing behavior, and relatively benign stall characteristics, all critical when preparing novice pilots for multi-engine and high-performance combat aircraft. Under the skin, the K-8's heart is its turbofan engine. Many export versions of the K-8 are powered by a single non-afterburning turbofan such as the Garrett TFE 731 series or similar powerplants adapted for the airframe. These engines produce sufficient thrust for typical training missions while maximizing fuel efficiency and minimizing operating costs. Some variants and operator configurations have used other engines such as the Ivchenko Progress AI-25 series or Chinese equivalents, depending on export restrictions, supply chains, and performance requirements. The single-engine layout simplifies maintenance and reduces logistical burdens compared to twin-engine designs while still delivering adequate climb rates and cruise performance for advanced training profiles. Performance figures vary with engine choice and configuration, but the K-8 generally offers cruise speeds in the transonic regime, service ceilings that allow for high-altitude instrument training, and ranges suitable for both pattern work and extended navigation sorties when fitted with ferry tanks. The combination of a reliable turbofan and straightforward systems architecture makes the K-8 attractive to air forces with limited maintenance footprints or those seeking a low-risk, proven training solution. Beyond the cockpit and propulsion, the K-8 is engineered with operational flexibility in mind. Standard configurations include multiple weapon hardpoints, allowing the aircraft to carry a mix of training stores, external fuel tanks, and combat payload. Typical stores can include rocket pods, small fixed-wing bombs, light precision-guided munitions where avionics allow, and gun pods are internal cannon options for weapons training. This versatility transforms the platform into a cost-effective light attack aircraft for counterinsurgency roles, border security, and close air support in low-intensity conflicts, where operating a high-end fighter would be unnecessary and cost-prohibitive. Training packages for the K-8 often include integrated simulation and ground-based training rigs that mirror cockpit layouts, allowing students to log procedural time without flight hours. Maintenance manuals, pilot training syllabi, and logistics support are often part of export packages, further reducing the barrier for new operators to integrate the aircraft into service. Cost is one of the K-8's strongest selling points and also a frequent source of confusion due to differing reports and configuration variations. The base price for a K-8 airframe is significantly lower than modern advanced trainers or frontline fighters, but the final program cost depends heavily on options, engine selection, avionics suites, weapons integration, spares packages, ground support equipment, training services, and long-term maintenance contracts. Publicly available estimates historically place the unit cost in the low tens of millions of US dollars range, with figures commonly cited around the mid-teens $million per aircraft for basic configurations. More feature-rich or weaponized variants, inclusive of support and training, naturally drive program costs higher. For many prospective buyers, the K-8 represents an economically attractive compromise, providing jet training capability with optional light attack functionality at a fraction of the acquisition and operating costs of more advanced types. The export success of the K-8, serving with several air forces across Asia, Africa, and Latin America, demonstrates its commercial viability and practical appeal. Operational advantages of the K-8 include straightforward maintenance procedures, relative parts commonality, and the ability to operate from austere airfields. Its predictable flight characteristics make it a forgiving training platform that still allows meaningful exposure to air combat maneuvers, formation flying, instrument procedures, and weapons employment. The K-8's limitations are equally clear. It is not a high-end combat aircraft, lacking the speed, radar signature management, and sensor fusion of modern frontline fighters. In contested or high-intensity conflicts, a K-8 would be vulnerable to advanced air defenses and high-performance adversaries. Its niche therefore is unmistakable, an intermediate trainer and light attack aircraft optimized for countries balancing capability needs against constrained defense budgets. For content creators and aviation enthusiasts preparing a YouTube segment, the K-8 offers a visually pleasing and narratively rich subject. Filming exterior close-ups of the wing root, intake, and canopy highlights practical design choices. Cockpit B-roll can underscore the instructor-student relationship and ergonomic layout. Engine panels and maintenance bays illustrate the maintainability story, and footage of weapons underwing or training sorties can show the platform's mission versatility. Interviews with instructors or former trainees would add credibility, while comparative sidebars, contrasting the K-8 with basic jet trainers or light attack alternatives, would help viewers appreciate why air forces choose this type of platform. Ultimately, the Hongdu K-8 Karakorum is best understood not as a high-performance centerpiece, but as a pragmatic, value-driven solution, an aircraft engineered to teach, to endure, and to provide light combat options when missions demand it, all while keeping costs manageable for the many nations that have adopted it.